Good evening. It's such a thrill for me to be able to host this tonight. I'm Scott Sayre. I'm the Chief Digital Information and Education Officer here at the Corning Museum of Glass. And I'm sincerely thrilled to have the opportunity to introduce this Connected by Glass program on a very timely and critical topic, the future of sustainable glassmaking. I have the privilege to introduce tonight's program as the chair of the museum's Green Team, along with my colleague Warren Bung, who's my co-chair. I don't know, Warren, if you're here tonight. There he is. I think we have some other members of the Green Team here tonight. The Green Team is a voluntary team of staff committed to researching and promoting environmentally sustainable practices and fostering a culture of shared responsibility through the museum's operations, facilities, and programs. Since we're on the topic this evening of sustainable glassmaking, I want to highlight a couple exciting accomplishments this year at the museum. First, working with our great colleagues from Corning Incorporated, of which many are here tonight, the museum has secured roughly 2,500 megawatts of renewable energy to power the museum. And this offsets about a third of our annual electricity usage. Many of you saw the electric hot shop earlier this evening, and it's great to say that that shop is now powered by renewable energy. This is really... Thank you. I feel very much the same way. It's a wonderful thing for us. This is really just the beginning of our renewable journey, but getting started, as I think our speakers tonight will talk about, is the hardest part, and so I'm really glad that we've made this step forward. Another highlight I want to point out is our new exhibit, Get Stoked, Fueling Furnaces from Wood to Sun. And this exhibit, thank you, explores the history of fueling glass furnaces, starting with ancient wood furnaces and concluding with renewable alternatives, including electric, methane, and hydrogen, which Mark will talk a little bit about tonight. The wood-fired furnace in this exhibition was constructed by the museum's hot glass team in support of our major exhibition, Dig Deeper, which I think we have a slide for. And I encourage you to see that. That exhibit has been a huge hit. And Dig Deeper is discovering the ancient glass workshop of Jalame. And I want to make a special shout out to our curator and colleague of mine, Kate Larson, who's the curator of ancient glass, who really led both of those. Before I introduce our special guests this evening, I want to take a moment to extend a warm welcome and thanks to a couple important groups. First off, to my many colleagues throughout Corning Incorporated, of which I know there's many here tonight, who really helped us build and shape our renewable program, as well as the many engineers and scientists who helped us with the Get Stoked exhibit. I really want to thank you. I know there are many Corning staff in the audience, and your support for the museum is really important to us, and we are so honored to have you here and really love your work with us on these collaborative projects. Last but not least, I want to welcome our promotional partner, Artists with Evidence. Artists with Evidence is a worldwide community of artists, scientists, and other innovators who promote evidence-based environmental solutions by forging innovative relationships between the sciences and the arts. Excuse me. Artists with Evidence is just one of the many communities that's joining us tonight. We have over 500 people in our virtual audience tonight because of this important topic. I want to welcome all of you. And the reason we're all here tonight is to hear Mark Steen and Karen LaMonte speak. Karen is a world-renowned American artist known for her life-size sculptures in ceramic, bronze, marble, and cast glass. Her recent works focus on clouds, climate change, and reflecting on her long-standing fascination with the themes of common and interlaced humanity. Karen will be sharing her personal journey as an artist to negate the carbon footprint of her personal work and her life. Mark Steen is the president of Sustainability and Climate Initiatives at Corning Incorporated. Mark will share his work at Corning Incorporated, the work Corning Incorporated is doing to minimize greenhouse gas emissions and developing new glass-based technologies to reduce carbon emissions and other products in industrial changes. Following their presentations, we'll have time for Q&A from both our in-studio audience as well as our virtual audience. And let's get started by welcoming Mark to the stage to get us started this evening.
Thanks, Scott. Well, thank you very much, Scott, and thank you to CMOG for having us here. It is really my pleasure to be able to be here and to share this stage with Karen, an artist whose work I've admired for years. So, you know, the work that Karen and I do is in some ways very different, but on the other hand, we really truly are connected both by our passion for glass and also for our dedication to sustainable practices. Climate change is one of the defining challenges of our time. And the core problem of climate change is actually relatively easy to state. We are putting massive amounts of greenhouse gases into the air every year, and that hurts our planet, and that hurts us. So when I say massive amounts, how much do I really mean? Well, it's the equivalent of about 55 to 60 billion tons of carbon dioxide per year. Now, numbers that large are really hard to get your head around. So let me try this. MIT points out that 1 ton of carbon dioxide would take up this volume of a cube about 8 meters, a little over 8 meters on the side. So 8 meters is roughly 3 stories high, and it also is roughly the height of this auditorium. So if you do the quick math, you will find that this auditorium would hold about 10 tons of carbon dioxide. 10 tons, okay. But how much is 60 billion tons? Well, let's think about it this way. If we had a layer of carbon dioxide that's about that high, about 3 stories high, how much area would that cover? Well, it would cover all of New York State, and also Connecticut, and Rhode Island, and all of New England. It would actually cover all of the states east of the Mississippi, and the states bordering on the Mississippi to the west, and North Dakota, and South Dakota, and Nebraska, and most of Kansas. So that is a large amount of carbon. Net zero is going to take us some work. Now, I'm sure that you have all heard the term carbon footprint. It refers to the greenhouse gas emissions that our actions create. So each and every entity, every person, every company, every museum, we all have a carbon footprint. And as I just talked about, the sum total of all of our carbon footprints on Earth is around 60 billion tons a year. So to stop climate change, we are all going to have to reduce our carbon footprints. Karen and I are each going to talk about our own efforts, Karen's efforts, and from my perspective, Corning's efforts to reduce our carbon footprints tonight. But I also want to encourage you to think about handprints. Handprints are the impacts of the actions that we take that encourage or enable others to reduce greenhouse gas emissions. So for instance, Karen's handprint comes from her excellent example and also her advocacy. Corning's handprint comes largely from products that we produce. So as you're hearing this tonight, I hope you'll think about both the footprints we're talking about and the handprint opportunities. Okay, with that as context, I'm really excited to hear about Karen's journey, and I'm sure you all are too. So Karen, why don't you come up and tell us about your journey.
All right, thank you very much. Welcome, everybody. When you think of who produces greenhouse gases, several culprits will jump to mind. the energy industry, transportation, manufacturing, and artists. You probably don't think of artists, but I do. And it's true that artists will not appear on anyone's list of worst offenders, but everyone has a carbon footprint. This means we all have a role in addressing climate change. I do not know exactly where I am on the spectrum of my peers, but I do know there are several factors that might make my artwork energy intensive. For example, I work on a large scale. This requires a large quantity of material. And I work with cast glass, which is an extremely energy-intensive process, more so than cast metals or stone. This is because kiln casting requires very high temperatures over a very long period of time to melt and anneal the glass. So I've always been aware of this. This is not a new realization in my life, and I've done everything I can to reduce the impact of my work and life on the environment. For example, I track how much electricity the equipment, each piece of equipment in my studio uses. Everyone is tagged. And I opt for green energy whenever possible. So buying slightly more expensive energy from the provider that's from renewable resources. And I also installed this giant heat recuperation system in my studio, which I affectionately call the Dragon. But in 2016, I had an aha moment that made me realize I had to do more. Some of you may know that I've had a lifelong obsession with clouds. I fell in love with them as a kid, and they've appeared in my artwork since college. I love the physicality of clouds, this effortless floating combined with a massive weight. In my mind, it's almost like magic. I love the beautiful way they transform light, and as a result of my new work, I've been learning what an important role they play in climate. I was working on my first cloud sculpture, Cumulus. Here you see me carving marble with a robot, which was so cool. And I wanted to sculpt a real cloud. I wanted the form to be scientifically accurate. So I worked with climatologists at Caltech to map, model, and measure a cloud. In fact, we were in the process of simulating the cloud for Cumulus when climatologist Tapio Snyder told me that carbon emissions are in danger of driving some cloud types to extinction. So for me, that was a gut punch. I think of clouds as eternal, and I also think of myself as someone whose life is about contributing beauty to the world, not taking it away. So I felt I needed to do more. This set me on a quest, which was quite complicated, to audit my global energy use, calculate my carbon footprint, and find out ways of becoming carbon negative. For this, I needed to do some mad math. So I called upon my studio manager and husband, the amazing Steve, to get into the numbers. So let's talk about my big fat carbon footprint. I started by looking at all the artwork I've made from 1990 when I graduated from college to 2020 when we did the calculation. We spent months adding up the weight of every sculpture and then used that weight to calculate the emissions from the raw materials, the casting, and the transportation of my artwork. We decided we wanted to be carbon negative, so that means offsetting more greenhouse gases than I had generated. At every single step, we rounded up, we exaggerated, we wanted to make 100% sure we were accounting for everything. Then, worried we might have missed something, we doubled the total emissions. So, Steve and I are not going to get any math awards, and you definitely do not want us calculating your taxes. But all of this was on purpose. We wanted to make sure we overestimated. So this is my total from 1990 through 2022. This is plus the 2 years since we did the first calculation. And I do believe that is the number that Mark said is the carbon that fills this room. So it took a lot of courage to look at the number, and then it also took a lot of courage to share it with everybody here in this room and all the people who are tuning in from abroad. I mean, it's kind of like getting weighed at the doctor and then posting it on Insta Extra Twittergram for the whole world to know. I mean, only someone who is totally out of their mind would do something like this. So I had a roller coaster ride after doing this math. My first thought was, mea culpa, holy bleep. I personally caused global warming and I should quit making art. Then my second thought, after re-engaging with the science and art of math, is that my carbon emission, my annual 1 year emission, is less than 0.00000003 of global emissions. I'm a small fry. Doesn't matter what I do, right? No. My final conclusion is it does matter, but quitting is not a solution, and I had to find some way forward that didn't do any harm and hopefully did some good. So, my first idea and first approach, my first pass, is to reduce and reuse. But at this moment, it's not really possible to reduce or reuse your way to zero emissions. So I started to learn about carbon offsets. It turns out, like everything, offsets are really complicated. For example, I love the idea of planting trees, but I learned that reforestation takes a very long time to capture CO2. And if anything happens to the tree, like 2023 summer of wildfires, or the actual natural cycle of the forest when the tree dies and the carbon goes back up into the atmosphere. So finally we found an organization called Cool Effect. I'm not in love with the name of the organization, but I do love what they do. Their scientists independently verify that their projects result in a net carbon reduction of greenhouse gases, and then it monitors them over time to ensure their long-term effectiveness. They have lots of great projects, but I focused on two main ones. The first distributes simple cook stoves in Uganda that reduce the amount of wood used for cooking by over 50%. That not only cuts emissions, it reduces deforestation and provides health benefits and cost savings to the Ugandan families. The reduced fuel consumption saves these families about $110 per year, which is 20% of their annual income. The second project is really glamorous. It's called Keeping Poop in the Loop. And this project supports farmers in rural China. Farmers raise lots of pigs. Pigs make a lot of poop. Poop creates a lot of methane. And the biodigesters that are provided capture that methane and use it to replace the dirty coal that's normally used for cooking. As a side effect, the poop turns into fertilizer, and there are a slew of economic and health benefits in addition to those I talked about. So it could be a little TMI, but I wanted to show you that quality carbon offsets provide environmental, economic, and social benefits that can go just beyond reducing my greenhouse gas emissions. So let's flash back to my big fat carbon footprint and the math. I was terrified that offsetting my emissions would be extremely expensive, but it turns out that offsets are surprisingly affordable. 2020 was definitely painful because I was paying for 30 years. But now that I do it yearly, it's much more manageable. My 2022 mad math exaggerated double footprint was 360 tons. So I paid around $4,000 for the offsets, which comes out to $11 per ton. So my goal, obviously, is eventually not to need any offsets, to have all of my energy come from green sources. And, I believe that as the grid decarbonizes, particularly with kiln casting, so will my work. But we're just not at that point yet. So this is my interim approach. The other thing I was worried about, other than finances, is that the whole process of becoming carbon negative would lead to restrictions in my studio work. And actually what I found out, or what I've experienced, is the opposite. I have gone on amazing new adventures, and I've met some amazing people, and new opportunities are opening up. One of my big mantras is material meaning. Materials have meaning. So I really do believe that materials impart meaning to an artwork. They're as important as form. Why else would I torture myself making cast glass? I started to think about recycled materials initially because of emissions. But then I quickly realized that the history of the material, its provenance, so to speak, can tell part of the story. I was lucky to meet the Patanos, which is a terrific family with a century-old recycling business. With them, this is my new studio. With them, I am working to make a 9-foot-tall cumulus cloud cast from scrap iron. We all know about the water cycle. Clouds make rain, fills ponds or the ocean, that evaporates and goes back up and creates clouds. I see a parallel between that water cycle and recycling. And in this case, I'm turning cars back up into clouds. I also decided to start recycling my own glass. There are always these little bits of extra glass that get cut off a big sculpture, like this lucent. And I've never reused the offcuts because it's risky. But to reduce my carbon footprint, I decided it was worth the risk to use the offcuts, and I cast this small sculpture. So that's the first successful interior. Finally, my sort of biggest adventure, I learned about a company called Solid Carbon Products. And of course, immediately when I heard the two words together, solid carbon, I was like, I wonder if that's a sculptural material. I mean, how cool would that be? So I went and visited Gaywin Quantz and Randy Smith, who turned out to be the coolest people. And basically in their basement, Gaywin and her late husband, Dallas Noyes, invented the Noyes process, which strips carbon molecules out of greenhouse gases, turning them into pure carbon powder. So instead of decarbonizing by adding a costly process, they're turning emissions into a profitable product, which is that's awesome. In my mind, it's like they're mining the sky and cleaning up the environment as they go. So they sent me 5 boxes of carbon to the studio so I could experiment. And what I've been doing is, these are just beginning projects, but this is what I call the long draw. I'm using capillary action to wick the carbon up over a period of days into various types of paper. Okay, so in conclusion, I believe we are in a critical transition period on the march towards sustainability, but we are definitely on the road. So during this time, as a studio artist, my mantra to myself is, do no harm, try to do a little bit of good, but definitely don't quit. Thank you.
So I loved hearing Karen tell about her decarbonization story, and she did a great job, because it really has a lot of parallels to what Corning's story is. And so I hope that you will hear those as I go through this. You know, one of the reasons that I think Scott asked us and CMOG asked us to present together tonight was to provide some contrasts between the individual and the corporation, between the artist and the technologist. But what's fascinating to me is how many threads sort of connect this together, and I think provide ways that we can learn from each other, but also inspire each other. I began this evening by talking about the global carbon footprint, which I pointed out is about 60 billion tons each year. So now I want to move a little bit more local to Corning Incorporated's footprint. Now, not surprisingly, ours is a little bit bigger and fatter than Karen's. It's about 10 million tons every year. Now, this includes all of our supply chain emissions. And to calculate it, we include many of the things that Karen talked about: raw materials, energy use, product delivery, travel costs, and actually a bunch of other categories. And this calculation, when we do it, it follows a strict set of rules, which is called the GHG protocol. And for transparency, we take that whole calculation and we put it on our website. So if anybody wants to look at it in more detail, you are welcome to. Just to harken back to what I said at the beginning, so 10 million tons, I talked about 60 billion covering most of the U.S. Corning's footprint, if you did the same thing, a 3-story high layer of carbon, would cover roughly about a fifth of Steuben County. So that's the size. That gives you a sense of it. Now, before I talk about what we can do to get rid of that, I want to acknowledge two fundamental realities at the center of our climate action challenge. First, as a technology innovator and a manufacturer, we have to acknowledge that what we do is inherently energy intensive. I mean, our work at its core is effectively pulling molecules apart and then putting them back together in novel ways. Physics tells us that that takes energy, and there is no way around it. Now, second, the material that's at the heart of our work, glass, presents some significant sustainability challenges. Most of us in this room are probably here because we have somewhat of a love affair with glass, and that's true of myself and my Corning peers as well. We frequently talk about the many attributes of glass that have made it such a transformative material. Its beauty, its strength, its versatility, its transparency, its impermeability. There are times when we may sound a little bit like we're doing our own version of "How do I love thee? Let me count the ways." But like many great love affairs, our relationship is complicated. And the reason is because glass also has many characteristics that try our patience. If you're a fan of the classic film When Harry Met Sally, you'll understand what I mean when I say glass is high maintenance. For example, melting and forming glass requires constant attention. Our furnaces run 24/7, often for years at a time, and during that time, unintended disruptions or miscues can take days or weeks of work to resolve. Glass can also be mercurial. Its physical properties change dramatically as it moves through its liquidus temperature, and if you don't treat it just right, that transition often becomes a transition into many small, sharp pieces on the floor. Our labs have been working with glass for over a century, and we are still trying to understand the relaxation of glass. Finally, glass can be intolerant of deviations. The same versatility that makes it possible to create almost innumerable varieties of specialty glass, all with distinct properties, also means that glass is highly sensitive to impurities and to minute changes in composition. So why am I talking about all of these trying attributes? Well, it's because to decarbonize glass, we're going to have to change the glass we make. But any change we make can have rippling effect through our entire processes and supply chains. So, like I said, it's high maintenance. Actually, that's a lesson that we learned when we set out to remove all of the arsenic and heavy metals from display glass in the early 2000s. Now, we did that successfully, and Eagle XG revolutionized the display industry. But to do it, we had to completely re-engineer the glass composition. Okay, so we've got 10 million tons to take care of and a high maintenance material. The next stop is to look at the sources and relative sizes of the greenhouse gases associated with Corning's operations. There are two big sources. The raw materials that provide the building blocks for our products and technologies, and the energy that powers our production processes, which mainly comes from electricity and natural gas to power our kilns and our furnaces. Now, the exact numbers depend on the year, but roughly speaking, those two sources together contribute around 2/3 of the greenhouse gases in our footprint. So let me talk about each one of them in turn and describe our efforts to reduce the impact. First, the input materials include things like silica, alumina, and various precious metals. The process of mining them and refining them and then transporting them all create greenhouse gases, and all of those greenhouse gases go into our footprint. Together, these goods that we purchase represent about 1/3 of the carbon dioxide in our footprint each year, which is over 3 million tons. We are pursuing 3 primary ways to reduce the greenhouse gases from our input materials. The first is reducing the amount of input material required. The second is using materials that have lower embodied carbon. And the third is to use recycled materials. So Viridian vials are a terrific example of reducing the amount of material required. Because of our expertise in creating strong, thin glass, we have designed and are producing these vials with 20% less glass than the incumbent vials. So that reduces the vial weight and therefore the embodied carbon. When we also use renewable electricity in the manufacturing process, the impact can be that these vials have as much as 30% less embodied carbon than the conventional vials. So we introduced Viridian vials to the world earlier this summer, and we are thrilled with their potential. But Viridian vials are just one example of a redesign that reduces greenhouse gases. Another example is the Edge Distribution System, or EDS product. Now, this is a product that connects the computers within hyperscale data centers. We designed EDS to allow customers to add capacity more quickly, consolidating dozens of patch cords into a single assembly and eliminating hardware along the way. Together, the consolidation of the cables and the minimization of materials and packaging result in up to a 55% reduction in carbon footprint compared to legacy solutions. So given how fast data centers are growing in the world, we are very pleased to be able to offer this low carbon solution. To facilitate more redesigns like these, we launched an initiative called Design for Sustainability. And I should point out that some of the people who launched that are in the audience tonight, so thank you. Design for Sustainability documents our approach. It captures best practices, and it allows us to make those processes repeatable. We are also undertaking a major effort to engage with our vendors, and some of those people are in the audience as well, to help our suppliers reduce their own carbon footprints. So when we put these efforts together, we fully expect to be able to meet our science-based goal of reducing our supply chain emissions by 17.5% between 2021 and 2028. As for using recycled inputs, this is actually my favorite method of GHG reduction, at least in principle, because recycled inputs move us a step closer to a circular economy in which we dramatically reduce the damage that can be caused by material extraction and also reduce the impact associated with landfill at the end of product lifetime. So I love recycled inputs, but this is where the complication of glass properties really surface. Commodity soda lime glass is relatively easily and economically recycled, but it's much more difficult to recycle the specialty glass that we produce, especially once it's gone into the products like cell phones or vials or displays or optical fiber. Widespread recycling of specialty glass will likely require the invention of new glass formulations that are less sensitive to common contaminants. It will also probably require new disassembly techniques, as well as higher volume methods of characterizing materials, and essentially a whole new value chain for the return of the materials, reverse logistics as they're referred to. And the economics of that value chain are completely unproven today. So, it's a daunting challenge. But it's the kind of disruptive innovation that Corning has produced again and again. And I'm hopeful that we'll be able to say more about our successes in reducing carbon from input materials over the next year or so. Okay, so that's our input materials. The other large category, if you recall, is energy to power our production processes. And that represents around 30 to 40% of our total greenhouse gas emissions. Now, to eliminate that carbon, we are electrifying every process we can, and then we're switching to renewable electricity for those processes. But there's going to be some left over, and for that, we will probably have to move to zero GHG fuels. Now, using low-carbon electricity is relatively straightforward. It's operationally transparent, by which I mean that the factory workers don't have to change their processes to use it, and it's readily available in Europe and the United States. It is not as easy to source in Asia, and that creates a significant challenge for us, but I'm cautiously optimistic that there will be more renewable electricity in Asia in the coming years. So this is an area where we've already made significant progress. In fact, we're particularly proud that the way that we create renewable electricity for our processes is that we are adding new renewable electricity onto the grid. For instance, one solar power plant that we financed has allowed our Harrodsburg, Kentucky plant to operate on 100% renewable electricity for the last 5 years, and actually longer than that. And we're currently financing the construction of a second solar installation that will provide us with roughly 290 gigawatt hours of renewable electricity each year. Now, we're already the fourth largest user of solar electricity in the United States among manufacturers. And we expect to be operating all of our US and European facilities on renewable electricity within the next few years. 100% renewable electricity. So if we can also get the cooperation of some partners and utilities in Asia, we hope those locations will follow closely behind. And if so, those moves together around renewable electricity will actually reduce 25% of our total emissions, including all of our supply chain emissions. And if you narrow it just to the emissions from our operations outside of the supply chain, it would reduce it by roughly 75% of our footprint. So, we've made a good start on renewable electricity. But, as I said, eliminating the residual greenhouse gases after electricity is going to take some work, and it may require the use of zero carbon fuels. Turns out that learning to melt glass with zero carbon fuels is challenging. Now, in some of our early experiments, We've already seen how one change, as I mentioned before, can affect many other things that we didn't expect. So for instance, the shape of the flame, if you use a burner that's powered by hydrogen, which is a zero carbon fuel, is very different than the shape of the flame if you're using natural gas. And so we have to make adjustments to avoid unwanted inclusions and variations in density. There are any number of other challenges related, but I wanted to share this one because I thought it was particularly interesting. You all may know that natural gas is naturally odorless and colorless, which creates a leak problem. It's hard to detect leaks. And so what was done many years ago with natural gas is people added an odorant. And so we're all familiar with the natural gas smell, and that helps us detect leaks. So hydrogen has the same problem. Hydrogen is also odorless and colorless. But here's the challenge. The odorant that's usually added is actually carbon-based. So if you do the same thing with hydrogen, you've lost your zero carbon fuel. So it's not a product problem per se, but it is a safety issue, and those are the kinds of things that we have to work on. Truly eliminating all of the natural gas we use is likely to take more than a decade. But I'm happy to share that we are making progress. In fact, at Sullivan Park, we have created this piece of glass, and also that piece of glass. These two pieces of glass are some of the first glass that we've ever melted with 100% hydrogen. So, yeah. Now look, I know that this doesn't look like much, but as soon as they melted it, I was like, hey, you guys got to send me a piece of that because I'm keeping it. You know, keep in mind that all great innovations start with a proof of concept. So I am thrilled that we've been able to make that proof of concept. This is pretty exciting to me. Okay, those are a few examples of how we're reducing our carbon footprint. But the truth is there's much more work to be done. And in fact, I can share with you a bit of a to-do list. So most of these things are actually quite hard to do. But if we can do them all, we will reduce 70% of Corning Incorporated's total global carbon footprint, including its entire supply chain. So we're working hard towards this. Now I'm going to switch gears on you. I talked at the beginning of tonight's presentation about handprints. So, you know, remember, handprints are the things that we do that enable and encourage others to reduce their carbon footprint. Most of our handprint comes from our products. And Corning's best-in-the-world capabilities, as we refer to them, actually provide us with a distinctively large and broad set of handprint opportunities. And I got to tell you that that's one of the most exciting things about working in sustainability at Corning, because this is something that not many companies can say. So we get excited about this. For instance, the combination of glass science and optical physics makes solar energy a natural fit. We already produce more polysilicon, which is the building block for solar cells, than any other company in the United States. And we're working on several technologies to grow that business further. Solar is going to play a major role in any decarbonization of the economy, and so the handprint from solar is going to be quite large. We are also improving energy storage with our work on solid-state batteries. As we all have experienced, batteries don't always last quite as long as we want them to. But solid-state batteries have a higher energy density than conventional lithium ions or lithium-ion batteries, and they're safer to boot. So one of the key requirements of making a solid-state battery is that you separate effectively the anode and the cathode, and our ribbon ceramics provide a way to do that with an ultra-thin barrier, helping to maintain and, in fact, increase the energy density of the battery. All right, one more handprint example. Because Most of what I've addressed tonight talks about stopping the flow of greenhouse gases into the atmosphere. But there's another problem, which is the cumulative effect of all the carbon dioxide and other greenhouse gases that have already gone into the atmosphere. So if the first problem is a flow problem, this is a stock problem. There's too much stock in the atmosphere already. If left alone, carbon dioxide can stay in the atmosphere for literally centuries. So, an important way to deal with this problem of existing atmospheric carbon dioxide may be direct air capture. And our low pressure drop, high surface area cellular ceramics could be the appropriate solution for this application. Now, I have to say, direct air capture is pretty controversial. It's the subject of vigorous debate. But if it does become a critical tool for the fight against global warming, we may be able to contribute an important piece of that solution. Another great handprint opportunity. I can't possibly share all of our handprint examples, but they are important ways in which Corning fulfills its mission of improving people's lives and creating a better world. So, look, it feels like every day that I find myself thinking, we have way too much to do and not enough time to do it to avoid the worst effects of climate change. But when I turn that around, I can think of it another way, which is there's so much that we can do now. There are technologies being invented that are going to make all of this better. It's going to be easier to decarbonize in the future. And Corning Incorporated is going to contribute some of those technologies. But we don't have to wait. Karen and I both talked about reducing footprints, individual or entity-based. That's something we can all do. But we can also do more. We can each increase our handprints. We can do that by the choice of events that we decide to go to or participate in. We can do it through our own advocacy. We can do it through our choices by choosing to buy low-carbon products. The things that Karen is doing, the things that Corning is doing, frankly, the things that CMOG is doing with the hot glass shop and the electric furnaces and the RECs, and frankly, by convening us here tonight. Those are all great examples of things we can do, and they all serve to inspire me. They keep me going to try and make sure that I am part of creating the solution to what is truly an existential problem. And I hope that they inspire you a little bit too. Thank you all for coming out tonight.
Thank you, Mark and Karen. So we're going to move into the Q&A part of the program. I wanted to kind of start it off by, Mark did a great job of ending his talk with, I think, his optimism for the future. And Karen, I wanted to ask you about your level of optimism.
Yes. Well, I'm very optimistic because, especially after listening to your part of the talk, I definitely have this sensation that we are in something like the green acceleration. There was something called the Great Acceleration at the end of World War II, where so much new innovation was happening that made life better for people and many things more possible. And I feel that something similar is happening right now, but it's a carbon-free version of that acceleration. So I think of it as the green acceleration. So it's exciting to learn more about it.
Yeah. That's great. That's great. So thank you, Karen. So we have, as I mentioned, a very large online audience, as well as a lot of people here. And I'm sure some of you have questions for our speakers tonight. So if you're online, please post your questions in the Q&A component in Zoom, and if you're here on site, just raise your hand. We have, and please wait until you have a microphone, so that our online audience can hear your question. And we have 2 people with microphones. Anybody want to start us out with a question? We have right here this gentleman in the center.
Thanks, Eric. So this is for Mark. I want to follow up on your solar and your sustainability. Why isn't there more solar in Corning? I have a house in Corning, and I've had complete solar array on my house. I haven't paid an electricity bill in 6 years. There are very few of us, very, very few of us. And Corning could show by example how much they could make. You have this facility up at Dick's. I understand that'll pay for maybe 1/3 of the electricity that's needed for Studio Next. That's an embarrassment. Why not? Solar all over Addison, the plants there, all over Sullivan Park, the valley here. You could run the whole place.
So we are increasing the amount of solar that we're using. As I said, we're building a new facility. It's actually in Albion, Illinois. The great thing about solar is that because you can't label electrons, when you put electricity onto the grid in one place, you're helping electricity in other places, right? So you get to pick and choose where the best locations are for your solar. So for instance, I know that we do not have enough room to create solar in the valley for what Sullivan Park and Corning headquarters uses. But what we do get to do is go to other locations in other facilities, either that we own or that we wind up financing, and use those areas to create more solar. One of the things that I'm excited about is, like I said, I think that within the next few years, I don't want to nail down an exact number, but a handful of years, we'll be running 100% renewable electricity for Corning Incorporated in the US and in Europe.
Thanks, Mark. Over here.
Thank you very much for your very educational and insightful talk. I love blowing glass. I'm an individual artist. I also love baking cookies, and I can't imagine telling people these cookies were baked in pig poop. What do you suggest the individual glass artists do in order to decrease their carbon footprint?
Is that a question for me?
I think so, Karen.
Well, you know, the interesting thing is I didn't have the opportunity, so I don't know what it looks like to try to assess the carbon impact of furnace work. You know, I was really focused on kiln work. And so it was very easy to put an energy monitor on the kiln. And what we did is we monitored a casting cycle, several casting cycles over the course of a year, and then took an average there. And then I applied that to on a per kilo basis to all of the work. So, you know, some method like that of figuring out how much carbon is being created by your work, and then just look at a different type of offset. You know, if the pig poop doesn't appeal. But you know, the thing about methane is 7 times more corrosive to the physical environment than carbon. And once it breaks down in the environment, it turns into carbon. So methane is pretty fabulous in terms of something ensuring that it doesn't get out into the environment. You know, it's a wonderful choice, you know, on sort of many levels, despite the fact that it's often associated with poop.
And we do in the Get Stoked exhibit upstairs, we have a panel about a studio, I think it's in South Carolina, that is completely fueled by methane off of basically a junkyard.
Oh, and I just want to add one little thing. New York City just announced that in 2024, all food scraps are going to be collected in New York City and composted. And they are building a composting unit. I think it's out in Brooklyn or the Bronx. And that composting unit is basically a biodigester. And all of that methane gas will be, tapped off and used for heating. So, methane is coming from decomposition of foods, as well. So.
I'm just going to add on to that because this is one of the things that makes sustainability, really exciting for me. So we talked a lot about climate change tonight. That's not the only dimension of sustainability. I touched a little bit on the circular economy. What I love is examples like this where we say, oh, look, we can take what would have been food scrap waste, turn it into fuel, and then use that methane to heat instead of releasing it into the atmosphere. Like, there's just so many wins involved in that kind of thinking that it gets really exciting.
Yes.
Richard has a question here.
Really a question for both of you, but I was really interested in the idea of the handprint. And I was thinking about the question for you, Karen, in as far as like you work with a number of foundries and areas that help you produce your work. Has your advocacy influenced their decisions? And conversely, at the other end, through museums and galleries that you work with and collectors, are you seeing any interest and any advocacy that's having an impact there?
It's very interesting. Definitely the places that I'm working with, it's on everybody's mind, but nobody has made the big moves yet. But I literally think it'll be a number of years, it's 1 or 2 years, before each of them are engaging with this kind of thinking. And it seems that on the other side of the coin, the younger collectors or environmentally focused collectors are appreciative, but I think it's a new part of the vocabulary for people. And so same way you were asking, what does the individual studio artist do? It's like, there's not really a roadmap for navigating this landscape, and so we're sort of patching it together by constantly doing research, reading newsletters, finding companies, and I think we're all going to become more fluent in this vocabulary with time, but I think, we're sort of, just a little bit avant-garde or whatever, doing something that I think shortly everybody will be doing.
We have a question from an online audience. I think we have time for one question.
Okay. This guest, a virtual guest, is saying, I'm specifically interested in sustainable practices in lamp working or flame working. Hydrogen is sometimes used as fuel gas in technical applications, but the near invisibility of the flame is problematic for more general use. In addition, the hydrogen flame is rather intense and too focused on many applications. Is there anyone working on this? I know some common torches can be used with hydrogen, but the intensity and visibility issues will probably call for some engineering.
Yeah, so great question. I don't know, Karen, if you have some thoughts about it. Okay, so there are several glass industry consortia that are working on specifically how to use hydrogen for glass making. So Corning's actually a part of a couple of them. And the question is exactly right. As I mentioned, part of the problem with hydrogen is that it's colorless and odorless as a gas, but also when it burns, it's very hard to detect, so there's safety issues there. So the answer is yes, there are people working on it. Unfortunately, I would love to be able to say, these are the things you should do, but I don't know what the answers are on how to solve that yet. So I think it's worth doing some research online and looking around. There are several glass companies working on this, and consortia specifically.
Well, we're at time. I want to thank all of you for coming tonight, and I give our guests a big hand for.
Yay! Woo!
And thanks to you and our online audience. If you want to stay in touch with upcoming series like this, please sign up for our mailing list. And have a great evening. Thank you very much all for coming and joining us.